Hi viewers, welcome to my channel SM EDUTALK. This is Dr.S.Malligarjunan. In the last video, projection of lines part 1, we have seen what is a line, its projections, positions and drawing procedure. In this part 2 video, we are going to see how to draw the projections of a line, especially when the line is inclined to both reference planes. If you have not subscribed the channel yet, please subscribe and click the bell icon to get notified. Okay, let us move into the video. I want to remind you of some important things before solving the problems in projection of lines. At first, you have to know the different types of lines used in EG and the corresponding pencil grades. Please watch the line types video for more information. I am telling this repeatedly in my every video because then only your presentation of the drawing will be good. In short, thick lines are used to represent the object and those lines must be drawn by the H pencil. In this topic, the projections of line are considered as the objects. That is, you have to use thick lines only to draw front view and top view of the given line. All the other lines in the drawing should be thin and drawn by 2H pencil. In projection of lines, as per syllabus, you have to draw only in first angle projection. I think you remember the first quadrant conditions, above HP and in front of VP. In this, for above HP condition, front view should be drawn above the XY line, and for on HP condition, front view should be drawn on the XY line. Similarly, for in front of VP condition, top view should be drawn below the XY line, and for on VP condition, top view should be drawn on the XY line. In projection of lines, the questions will be asked from the fourth line position only, that is inclined to both the planes. There are two methods to draw the projections of the line. 1. Rotating line method. 2. Rotating plane method or trapezoidal method. But the syllabus covers rotating line method only. Now we are going to see step-by-step drawing procedure to draw the projections of the line using rotating line method. Draw the projections of a line MN. First, a reference line XY should be drawn. Line MN has two endpoints M and N. A horizontal line should be drawn above the XY line using the above HP condition. This is called as locus of M dash. Similarly, another horizontal line should be drawn above the XY line. This is called as locus of N dash. To draw this line, either above HP condition or some other data may be given. Again, one more horizontal line should be drawn below the XY line using the in front of VP condition. This is called as locus of M. Finally, last horizontal line should be drawn below the XY line. This is called as locus of N. To draw this line, either in front of VP condition or some other data may be given. No view has got true length in inclined to both the planes problems, but it is not possible to draw the projections without drawing a true length line. So, an inclined true length line should be drawn to connect the two locus lines situated above the XY line. It is named as M dash N1 dash. It makes a true inclination with HP theta. Both the endpoints of this true length line are projected to the locus of M vertically downward. They are intersected with the locus at M and N1. An arc should be drawn with M as center and N1 as radius to cut the locus of N that creates an intersecting point N. A line which connects the points M and N is called as top view of the line MN. It makes an apparent inclination with VP beta. Always top view's length is less than the true length. That's why its length is termed as apparent length. It is important to note down here MN equal to MN1. That is top view length equal to distance between the projected points on the first endpoint locus. Keep this in your mind. It will be helpful when solving the problems. What we did so far, the true length line drawn above the XY line is projected below the XY line up to first endpoint locus. Then it is rotated to second endpoint locus to get the top view. Now it should be reversed. That is, the true length line drawn below the XY line should be projected above the XY line up to first endpoint locus. Then it should be rotated to second endpoint locus to get the front view. So an inclined true length line should be drawn to connect the two locus lines situated below the XY line. It is named as MN2. It makes a true inclination with VP phi. The point N2 is projected to the locus of M dash vertically upward. It is intersected with the locus at N2 dash. An arc should be drawn with M dash as center and M dash N2 dash as radius to cut the locus of N dash that creates an intersecting point N dash. A line which connects the point M dash and N dash is called as front view of the line MN. It makes an apparent inclination with HP alpha. Always front view's length is less than the true length. That's why its length is termed as apparent length. It is important to note down here M dash N dash equal to M dash N2 dash. That is, front view length equal to distance between the M dash and N2 dash on the first endpoint locus. Please keep this also in your mind. It will be helpful when solving the problems. Connect the points N dash and N by a projector. Dimension the given data on the drawing like true length, inclinations, etc. Don't worry if you're not able to understand. I'll explain with a real problem. The end A of a line AB is 10 mm above HB and 15 mm in front of VP. The true length of the line is 60 mm and is inclined at 30 degree to HP and 45 degree to VP. Draw the projections. Given data, it is given that true length of the line AB equal to 60 mm. True inclination with HP, that is theta equal to 30 degree, and true inclination with VP, that is phi equal to 45 degree. Now we are going to see how to draw the projections of the line AB with the given data. That is, we will see how to draw front view and top view of the line AB. First, draw a reference line XY. You cannot draw a line without knowing its length. In addition to length, both the endpoints positions are required, or one endpoint position and line inclination are required to draw a line. In this problem, line AB's true length, endpoint A's position and its true inclination are given. Using this data, you can draw a line. The endpoint A's position is given as 10 mm above HP and 15 mm in front of VP. For the first condition, 10 mm above HP, front view of point A should be drawn 10 mm above the XY line. But here, instead of drawing a point, draw a thin horizontal line 10 mm above the XY line. Mark a point anywhere on the left side of this line. This is the front view of the endpoint A dash. We call this line as locus of A dash, in which point A dash is marked. Next condition, 15 mm in front of VP. So top view of point A should be drawn 15 mm below the XY line. But here also, instead of drawing a point, draw a thin horizontal line 15 mm below the XY line. This is locus of A. Now project the point A dash to locus of A vertically downward. It intersects the locus at a point A, which becomes the top view of the endpoint A. The position of endpoint B is not given in the question. Instead of the position, its inclination and length are given. The line AB is inclined at 30 degree to HP. Always, HP condition refers the front view. In first angle projection, front view should come above the XY line. Hence, draw a thin line from the point A dash which is inclined upwards at 30 degree to XY line or locus of A dash. Draw an arc with A dash as center and true length 60 mm as radius. It cuts this inclined line at B1 dash. We can call this line as true length line. I already told you we won't get true length in inclined to both the planes problems, but it is not possible to draw the projections of the line without true length. That's why here a true length line has been drawn. Using this line, we will draw the top view of the line AB. Now, draw a horizontal thin line through the point B1 dash. This line is called as locus of B dash. Project point B1 dash to locus of A vertically upward. You will get point B1. Draw a thin line from the point A which is inclined downwards at 45 degree to XY line or locus of A. Mark true length 60 mm on this line using a compass or any normal scale. After marking the true length, you get a point B2. This line is also called as true length line. Draw a horizontal thin line through the point B2. This line is called as locus of B. Next, draw an arc with a point A as center and AB1 as radius. It cuts the locus of B at point B. Join point A and point B by a thick line. This AB line is the required top view of the line AB. Project point B2 to locus of A dash vertically upward. You will get a point B2 dash. Draw an arc with a point A dash as center and A dash B2 dash as radius. It cuts the locus of B dash at point B dash. Join point A dash and point B dash by a thick line. This A dash B dash line is the required front view of the line AB. As per orthographic projection, front view and top view should be connected by vertical projectors. In this drawing, on one end, the points A dash and A are connected already. To connect the other endpoints, draw a projector to join the points B dash and B. If this connecting line or projector is vertical, then what you draw is correct. Otherwise, it is wrong. So, connecting the endpoints by a projector is a way of checking the correctness of your drawing. Drawing has finished. Now, dimension the given data in the drawing such as true length 60 mm, true inclination with HP theta that is 30 degree and true inclination with VP phi that is 45 degree. If not done, there may be some other questions to be asked apart from the drawing. If you are asked to find the apparent length of the line AB in front view, that is length of front view A dash B dash, or the apparent length of the line AB in top view, that is length of top view AB, then you can use any normal scale to measure the length of these lines and write your answer. If you are asked to find the apparent inclination of the line AB in front view, that is angle of front view alpha, or the apparent inclination of the line AB in top view, that is angle of top view beta, then you can use a protractor to measure the inclination of these lines and write your answer. You are advised to use H pencil to draw thick lines always. In this drawing, the required objects are the projections of the line AB, that is front view A dash B dash and top view A B. So, you should have drawn these views thick. Apart from these views, all the other lines are drawn as thin lines by 2H pencil. Next problem. The end P of a 70 mm long line PQ is 15 mm above HP and 20 mm in front of VP. Q is 40 mm above HP. Its plan is inclined at 45 degree to VP. Draw the projections and find its true inclinations. Given data. It is given that true length of the line PQ equal to 70 mm. Also, it is mentioned that plan is inclined at 45 degree to VP. In engineering graphics, front view is also called as elevation and top view is also called as plan. So, what is given here is top view's angle, that is apparent inclination with VP beta equal to 45 degree. Now we are going to see how to draw the projections of the line AB with the given data. First, draw a reference line XY. The first endpoint P's position is given as 15 mm above HP and 20 mm in front of VP. For the first condition, 15 mm above HP, front view of point P should be drawn 15 mm above the XY line. So, draw a thin horizontal line 15 mm above the XY line. Mark a point anywhere on the left side of this line. This is the front view of the endpoint P, P'. We call this line as locus of P' in which point P' is marked. Next condition, 20 mm in front of VP. So, top view of point Q should be drawn 20 mm below the XY line. So, draw a thin horizontal line 20 mm below the XY line. This is locus of P. Now, project the point P' to locus of P vertically downward. It intersects the locus at a point P, which becomes the top view of the endpoint P. The second endpoint Q's position is given as 40 mm above HP. So, draw a thin horizontal line 40 mm above the XY line. This is called as locus of Q'. Draw an arc with P' as center and true length 70 mm as radius. It cuts the locus of Q' at Q1'. Join P' and point Q1' by a thin line. We can call this line as true length line. Project point Q1' to locus of P vertically downward. You will get a point Q1. We need two locus lines to draw the top view, but top view position of endpoint Q is not given in the question. Then how do you draw the locus of Q? Do you remember what I told you while explaining the drawing procedure? That is, the distance between the points P and Q1 in the first endpoint locus is equal to the top view length PQ. That is PQ1 equal to PQ. So, rotate PQ1 to get the top view PQ. To do so, draw an arc with P as center and PQ1 as radius. Top view's angle beta is given as 45 degree. Draw a thin line from the point P which is inclined downwards at 45 degree to XY line or locus of P. This inclined line intersects the arc drawn earlier at point Q. Join point P and point Q by a thick line. This PQ line is the required top view of the line PQ. Now draw a horizontal thin line through the point Q. This line is called as locus of Q. Draw an arc with a point P as center and true length 70 mm as radius. It cuts the locus of Q at point Q2. Join point P and point Q2 by a thin line. This thin line represents the true length line. Project point Q2 to locus of P' vertically upward. You will get a point Q2'. Draw an arc with point P' as center and P' Q2' as radius. It cuts the locus of Q' at point Q'. Join point P' and point Q' by a thick line. This P' Q' line is the required front view of the line PQ. To check the correctness of your drawing, draw a projector to join the points Q' and Q. If this projector is vertical, then what you draw is correct. Otherwise, it is wrong. Drawing has finished. Now, dimension the given data in the drawing such as true length equal to 70 mm, apparent inclination with VP beta equal to 45 degree. If not done, you are also asked to find the true inclinations. You can use a protractor to measure the angle of true length line theta, which is located above the XY line, and the angle of true length line phi, which is located below the XY line. After measuring the angles, you will get theta equal to 28 degree and phi equal to 41 degree. It is difficult to cover all model problems of projection of lines in a single video. So please wait for my other videos which cover the remaining problems in projection of lines. If you have not subscribed the channel yet, please support me by subscribing. Don't forget to click the bell icon. By doing so, you will get the notifications regularly. Also, share this video to your friends. Thank you.